Good day, this is Petrus de Kok and this is my final video for my submission of my project. So I'm going to start with my presentation. As you can see here, my project is concerning biotechnology, but not biotechnology in its own sense, but the equipment used in biotechnology. Since the cost of the equipment is a big barrier towards people who are qualified and do not have access to a laboratory. Just a simple static temperature controlled cabinet can cost 20,000 to 70,000 rands. The parts that I am responsible for coding in this project are the relay, which switches on the heating system for the temperature, and the resistor or photo sensor that can use light to increase the resistance, and by doing that it can switch on an LED, tell you the door is open in this case, or what's also important is it can monitor the amount of light present in the incubator, because some organisms are photosensitive and will travel towards light, which can mess up your petri dishes. In this schematic you will see that the parts circled in red are the parts I are responsible for. You have your LED with the 330 ohm resistor and a LCD, yes, over here, and the DHT22 sensor, and LDR, and a 10 KO pull down resistor for the LDR to make to help with the readings from the LDR. In this flowchart, the program starts, predefined processes start, and then you define your variables. You get your libraries. You also set your address for your LCD. Then next you will start your LCD, you will start your serial port that you use for fault finding. And you set things like your millis variable, you also set what's your input, what's your output, and then you continue on towards the void loop. In the loop you define your variables that are only responsible for the loop. As you see, there's a current millis and a T variable. The T variable is the temperature divided by the required temperature. This will be important later. And the current millis is just subtracted from the millis, which is the internal clock speed of the Arduino, which and the interval, which was also predefined earlier, is just 2 seconds, because the DHT22 sensor especially needs 2 seconds to update itself. Then you have your if, where you basically find your interval. After this you do everything that is there. You read all your values from your analog inputs and from your sensors. Then the temperature sensor is temperature which is divided by the temperature that you want, which is 31 degrees in this case. And then if it's less than 1, it means it's greater than the value needed, less than the value needed, sorry. Then it will switch on. If it's greater than that value, it will switch off. If it's greater than that value, then it means if you take 31 and you divide it by 16, you divide it by 30, then it's greater than 1. It shouldn't switch on. So the next one, it just checks whether the sensor is high, the light sensor is high, and if the light sensor is high, it will basically switch on the LCD and writes that the door is open, else it will just switch off and tell you the LCD is tell you nothing. And this whole process, this whole loop will repeat over and over again, because we're working with the Arduino, not with the normal software. Okay, here's a block diagram. As you can see, here's the Arduino, and here are the inputs and the outputs. The LCD, the relay are the outputs, and the relay is the output towards the load. The inputs are the LDR and the DHT22 sensor. And the parts that I was responsible for were the LDR and the relay. Okay. Here you can see the PCB that I designed. The pin 4 and pin 5 here are different than they were in the schematic, as you can see, because if you connect it here, you will basically connect pin 5, then pin 4, not pin 5 and 4 and then 5. And then you here have the 10k ohm resistor, your LDR, the LED, the 330 ohm resistor. Here's the relay with its two V-ins and its output and its input from the pin and its ground. All of it's nicely done there. And this is how it would basically fit on a Arduino. Okay, on a breadboard my project worked perfectly. And even now it's still functioning as it should, as you will presently see with the presentation. But what I did there that I can do better is, when I was demonstrating how it worked, I went and cooled the sensor down in a strange way. What I'm going to do now, I'm just going to simulate the changes in temperature by uploading the code changes, and then you should be able to see the differences. As you can see, this is the project. It shows the temperature as 32 degrees Celsius and the humidity of 22.3, and the LED is off, as it should be, because the temperature is too high. Okay, now maybe if I open it up quickly, you will see that if I open it up, then it will say, okay, I know it's wrong side up, but the door is open. I can also do it like this. Ah, no, not enough light. The door is open. It sticks to that 31 plus degrees Celsius at the moment, because it is summer here, summer at the moment. So if I go here and I change the 31 to, oh wow, it's supposed to change it back to 20, change it to 25 for the previous indication. I'm going to change it to 35, for instance. So going to upload it. You can see the LED has now turned on after I changed that. So I'm quickly going to change it this time to 31 degrees Celsius. Okay. Okay. As you can see, it reset, and it still stays on for that couple of seconds, and then it switches off again, because it's now above 31 degrees Celsius. So it doesn't need to stay on. So it functions perfectly. Thank you for watching, and goodbye.